In this video, we're continuing with lesson 6-2. This is video number 5. I'm on page 16 in the note packet. So this is example 5. Again, it's a, I have it underlined for you here, continuously compounded example. So that means we're going to use the PERT formula. So let's see if we can label these pieces up here. So suppose you deposit $1,100. So this is your initial amount. And in that formula, we call that P. So I'm going to say P equals 1,100. I'll get a different pencil here. Paying, there's your interest rate, 5.5% interest. So remember, we want to divide that by 100. So we're going to get R equals 0.055. Compounded continuously, and here's their time. So T is 12 years. Use the PERT formula, and then it says, what are we solving for? Well, up here it says, what is the balance? So they're asking, if I put $1,100 in for 12 years, how much will I have? So that is the final amount, which in our PERT formula is our A. Okay, so let's copy our formula. A equals P times E to the R times T. And let's plug in the pieces. Well, we already know we're solving for A. So A is going to be our unknown. Our principal is 1,100. E, that's our E on our calculator, our exponential function, to the R, which is 0.055 times T, so times 12. And remember I said put this part in the calculator first. Oh, look, that, I already did it. So 0.055 times 12 is 0.66. So the next step, copy the 1,100. Haven't done anything yet there. And all I've done here is multiplied those two to get the 0.66. Okay, now this entire line here we can put in the calculator. Remember, A is what we're solving for. So I'm going to say A is going to be equal to, and I'm going to put all this in the calculator. So 1,100 E, so remember my E is right here. It's the second function of that natural log button. So second E, and it automatically makes it an exponent. And in there I want to put 0.66, and then make sure you close that parenthesis, put that right parenthesis, and hit enter. So I get $2,128.27. So what did I start with? 1,100. Yeah, that sounds reasonable. So my final amount is going to be 2,128.27. Remember, we always want 2 decimal places for money, because that's 27 cents. If I look at the number after the 7, it's a 1. It's less than 5, so I keep the 7 a 7. Make sure you're using your rounding rules in that. Okay. Now what does part B say? Part B is a how long. So whenever you see those how long, that tells you T is your unknown, what you're solving for. Will it take the balance in your account to reach $2,000? So I'm still putting the 1,100 in, and it's asking how long till I get to 2,000. So this is my final amount. And remember, the final amount is your A. So what are we solving for here? Time, because the question is asking how long. That's time, right? When solving for time, which we are, we use the graph. But let's write everything out. So I'm going to copy my formula again. So I recommend you do this also. The more you copy this formula, the better you get at using it, and you might also memorize it too. So I'm still starting with that 1,100. Oops, 1,100. still have E, same interest rate, so 0.055 times T. There's my unknown. And then over here I have my 2,000. Now remember, I'm putting this in Desmos. And then I want to see when my X, what X value will give me a Y value of 2,000. So I'm going to do this fancy camera trick again here. Let you see my screen. And what are we putting in? We're putting in 1,100. Let's get that a little closer for you. 1,100 E to the 0.055. And remember, you have to make that an X when you put it in Desmos. So if I look over here, I don't really see a graph. I think it's because this number is 1,100, so the graph is, there it is. You gotta zoom way out to see it. But remember, we're mostly interested in the table. So click on your gear, click on your table. And the question asks how long to get to 2,000. So this tells me after 2 years, or X is 2, my Y is, looks like 1,200. So I need something bigger. So I'm just gonna check 5 and see what happens. So that's 1,400. Remember, I'm checking for 2,000. So I'm gonna see about 8, getting closer. I'm now at 1,700. Let's check 10. I feel like that's gonna do it. Oh, so close. 1,900, so now I'm just gonna go up 1 year at a time. There we go. So at X equals 10, the Y is 1,906. And then this is over 2,000. So where do I reach 2,000? Between X equals 10 and X equals 11. Or for our case, remember our input or our X's represent time. So this is going to be, let me raise this up a little bit. So this is going to be between 10 and 11 years. So that's how long it will take to get $2,000. So now this is, says part B. This should say part C. Change that to part C. So part C says, how much should you invest today? So this is your starting amount. So my starting amount is my question mark. And remember, in our formula, our starting amount is our P. So P is what we're solving for. In order for you to have at least $3,000, so this is my final amount. So that means my A is 3,000. 12 years, that means T is 12. So use the PERT formula. What are we solving for? Well, we already decided we're solving for the initial amount. So this is a good problem. Say you're saving for something. I don't know, you could be saving for a car, $3,000. And you want to know, okay, I want to buy a car in 12 years. How much do I need to put in the bank today so that I'll have the $3,000 in 12 years? So if you think about our formula, A equals PE to the RT. I wrote that wrong. A equals P times E to the R times T. What is going to stay as our unknown is our P. Our final amount is $3,000. P is what we're solving for. E is a function, remember. R is the same all the way through this problem, so that's 0.055. And then T in this part C is 12 years, so I'm going to put that in. So again, multiply those out. Copy everything. This is going to be E to the, oh, there's a different calculator this time, just so you can see different calculators. 0.055 times 12. So that's, oh, we must have done that already. 0.66. Yeah, we did that up here. Or look up and use what you've already done. Okay, so now I have an equation. Remember, this is just a number that I can put in the calculator. So let's do that. And then I'm going to continue this over here. Important to keep copying this information. Keep everything nice and neat. Now all I'm solving for now is e to the power of 0.66. So on this calculator, here's my natural log, here's my e. So I'm going to do second e, puts the e on the screen, jumps it up to an exponent. I'm going to put 0.66 and then just hit enter. So there we go. Remember, e is just a number. It's like 2.71. 2.71 to this exponent is going to be 1.9348, I'm going to say. 1.9348. So I just replaced this with that 1.9348. There's my unknown, p. Still have to solve for p. So this is p multiplied by this 1.93 number. So to undo multiplication, I want to divide both sides by that 1.9348. So over here, 1.9348 divided by 1.9348 is just p. So there we have p by itself. And this you're going to want to put in the calculator. So I'm going to do $3,000 divided by 1.9348 equals 1550. And this is money. Point. I want 2 decimal places. The number after the 4 is a 7, which is bigger than 5. So I'm going to bump that 4 up and make this 55 cents. Okay. Now, before I put a box around this, I want to see if that makes sense. Remember, I'm ending with 3,000, and what the question was asking is what do I have to start with? So this is how much I have to put in the bank. That does make sense. And then after 12 years, I'll have the 3,000 I need to buy whatever I'm saving for there. Okay, this next one is your turn. I want you to pause the video and try this, but I'm actually not even going to work it out in the video. So what you might want to do is copy these answers down and then go back and try to solve it on your own. Okay, so the first one, that's your answer. That's what you should get. The second one is between 65 and 66 years. So this is the one you're solving for time because it says how long. So you're putting this in in Desmos. When you put this in Desmos, I'm going to say a little hint is start the X value in your table, right? You don't want to start at 1 or 2 or 3 because I'm already telling you it's way up here. So start at like 60 and see if you can see where we get to that 5,000. That's it for this video.